we will be discussing in this lecture is agent discovery. So this is used to identify an mobile node when the mobile node moves from the home network to foreign network. So when the mobile node is in the foreign network, the mobile node should be identified and it should be allocated with the new address, new IP address. Okay. That process is called as agent discovery. And there are two ways in which agent discovery can be done. It can be done either through agent advertisement or through agent solicitation. So first let us discuss about agent advertisement. So these agent advertisement messages are sent as beacon broadcast messages into the subnet. And these advertisements are basically ICMP messages. These are basically ICMP messages according to RFC 1256 with mobility extension. These are ICMP messages with mobility extensions. Okay. Routers in this fixed network implementing this standard also advertise their routing service periodically to the attached links. So whatever the routers connected to this particular uh, foreign agents, so they will also advertise these links frequently. Okay, so basically these are advertised by foreign agents. This agent advertisement beacon messages, basically these are advertised by foreign agents. So the agent advertisement message, it contains two parts. The upper part represents the ICMP packet. The upper part represents the ICMP packet, while the lower part provides mobility extension. While the lower part is the extension needed for mobility. Fields necessary on the lower layers for the agent advertisement are these things. Type, there is a type field, there is a length field, there is a sequence number, there is a registration lifetime, and there are some other fields which we will discuss during this lecture after some times. Okay. So the advertisement packet, it contains two parts. The upper part is ICMP packet. The lower part is the mobility extension. So mobile nodes must be reached with the appropriate link layer address. The TTL field of the IP packet is set to 1. It is time to live. The TTL packet is set to 1 for all advertisements to avoid forwarding them. So the advertisement need not be forwarded further. So TTL will be set to 1 so that it will not be forwarded. Okay. The IP destination address according to standard router advertiser can be the IP destination address can be either set to 24.001, which is a multicast address for all systems on the link, or to the broadcast address 255.255.255.255. Okay. The fields of the ICMP packets are, so as we already discussed, the advertisement packet contains two parts. The upper part is an ICMP packet and the lower part, the upper part is the ICMP packet and the lower part is for mobility extension. So the various fields of the ICMP part are type. There is a type field in the ICMP part of the advertisement message, which is set to 9. Is set to 9, and there is a code field which is set to 0, which is set to 0 if the agent also routes traffic from non-mobile nodes. Okay, so code will be set to 0 if the agent also routes packets from non-mobile nodes. Otherwise, it will be set to 16, which means it routes packet only from mobile nodes. Okay. So foreign agents are at least required to forward packets from the mobile node. Foreign agents are at least required to mobile node. So this is the agent discovery message structure. So here we can see the top part, it is basically an ICMP message. And in the bottom part, the mobility extension feature is added. So, so, so the so we are talking about the ICMP part. So there is a type which is set to 9 and code is set to 0. If the agent also routes traffic from non-mobile nodes, otherwise it is set to 16. Okay. Foreign agents are at least required to forward packets from the mobile node. Okay, so if the mobile node is moved to a foreign network, and if that mobile node want to communicate, then the foreign agents uh, should uh, should uh, should be required to forward those packets. Okay. The number of addresses advertised with this packet is the number of address advertised with this packet is given as hash address. Okay. While the addresses themselves follow, uh, while the addresses themselves uh, will follow a particular structure, and there is a field called lifetime, which denotes the length of the time this advertisement will be valid. And also there is something called as preference level for each address. There is something called as preference level for each address to help a node to choose the router that is most eager one to get a new node. Okay. So preference basically it is used to identify the right router. So so the difference compared with ICMP advertisement is is what happens after the router addresses. Okay. So this so the lower part of the message, it contains extension for mobility, and it has the field type which is set to 16. It has the field type. There is a field type, and that is set to 16. And the length field, it depends on the number of COAs provided with the messages. Okay. An agent shows that the total number of advertisements sent since initialization in the sequence number. There is a field sequence number in the mobility extension part. Okay. So, uh, so this sequence number, it contains the total number of advertisement sent since initialization. Since initialization, how many advertisement were sent? So that will be stored in the that will be stored in, and that will be stored in the sequence number. Sequence number contains the number of advertisement that were sent since initialization. Okay. So there is another field called registration lifetime. There is a field called registration lifetime. Basically, this field represents the maximum lifetime in seconds a node can request during registration. It represents the maximum lifetime in seconds a node can request during registration. So that is so that is called as registration lifetime. Okay. So there is a OR bit. There is a OR bit. If a registration with this agent is required, uh, if the registration with this agent is required, even when using a collaborated CO at the MN. So OR bit says uh, whether the registration with the agent is required or not. Whether the required whether whether the registration with the agent is required or not, even when using a co-located CO at the M1. This if the co-located CO at the if it is at the M1, then the registration with the foreign agent is required or not required. So that is what this particular field contains. Okay. So that is what orbit contains. So orbit contains whether the registration with the agent is required or not, even when using a co-located COE. Okay. If the agent is currently too busy to accept new registration, then it can set the B bit, and it can use the B bit instead of the A bit. So, so there are two bits which represents whether the agent is offering any uh, whether the whether the agent is offering any service as home agent or foreign agent. So whether it is working providing any service as home agent or foreign agent, that is represented through the attributes H and F. It is represented through the attributes H and F. And there is bits M and G. There are bits M and G which specify the method of encapsulation used for tunnels. It specifies the method of encapsulation used for tunnels. Okay. And bits M and G specified the encapsulation used for tunnels. Okay. And there is something called as IP in IP encapsulation is used for is, is a mandatory standard. IP in IP encapsulation is a mandatory standard. M can specify minimal encapsulation, and G represents generic routing encapsulation. So M represents the minimal routing encapsulation, and G represents the generic routing encapsulation. So and there is a field called OR. It is set to 0 and it must be ignored. And there is a field T which indicates that the reverse tunneling is there is a field T which indicates that the reverse tunneling is supported by FA, by the foreign agent. And there are fields that contain COAs advertised. There are fields which contains the COAs that were advertised. A foreign agent setting the F bit must advertise at least one COA. The foreign agent which is setting the F, the foreign agent. Oh, yeah, the foreign agent which is setting the uh, F bit, okay, must advertise at least one COA. Okay, there is an F bit. If this F bit is set, then at least one COA must be at least advertised. Okay. A mobile node in a subnet can now receive agent registration from either its home agent or from a foreign agent. Okay. So the mobile node can receive the agent registrations either from the home agent, or it may also receive it from the a foreign agent. Okay, from somewhere else, it will receive the advertisement. Okay. This is and once it is received, then the mobile node will respond. So this is one way for the mobile node to discover its location. This is the first way for discovering the mobile node's location. Okay. So the second method is by using a technique called agent solicitation. The second method is uh, by using a technique called agent solicitation. Okay. So what this technique says in the sense, if no agent advertisements are present, if no age, if no agent advertisements are present, or the enter arrival time is too high, and an MN has not received COA by other means, okay, because of these reasons. If no agent advertisements are present on the inter-arrival or the inter-arrival time is too high and an MS has not received a COA by other means. So that is if an MN has not received any COA till now and it has not received any beacon signal, then this agent solicitation message can be used. Okay. So the mobile node must send solicitations because there is no registration thing from the base station. Okay. So I mean from the LA or FA. Okay. So the mobile node must send the uh, agent solicitation message. The mobile node should send the agent solicitation. Okay. So basically, these solicitation messages are based on RFC 1256 specification. These are based on RFC 1256 specifications. Okay. So care must be taken to ensure that these solicitation messages do not flood the network. Okay. So we should ensure that these solicitation messages do not flood the uh, network. Okay. Uh, but basically, an MN can search for uh, and FA endlessly, sending out the solicitation messages. Typically, a mobile node can send out 3 solicitations, one per second. Normally, the mobile node can send 3 solicitation, uh, one per second. Okay. And uh, a mobile node can send 3 solicitation, one per second, as soon as it enters the new network. Okay. It should be noted that in dynamic wireless networks with moving mobile nodes and probably with the application requiring continuous packet streams, even 1 second interval between solicitation messages might be too long. Okay. So before an M1 even gets a new address, many packets will be lost without additional information. So, so, so basically it means that the mobile node should be given IP address as early as possible. Otherwise, uh, uh, otherwise, uh, otherwise it will become. Otherwise, there will be lot of loss of information. There will be lot of packet loss. Okay. If a node does not receive an answer to its solicitation, assume a node is sending a solicitation message, but there is no response, there is no answer for the solicitation message, then it must decrease the rate of solicitation exponentially to avoid flooding. So initially, uh, if the solicitation message is not allowed, if the solicitation message is, if the agent is not advertised, then it will send the solicitation message. For that, the mobile node should respond. Okay, for that the mobile node should respond. Okay. If a node does not receive an answer for the solicitation message, then it must decrease the rate of solicitation exponentially. How frequently it will give solicitation, that should be reduced exponentially. Okay, until it reaches a maximum interval between solicitation. So discovering a new agent can be done anytime, not just if the M1 is not connected to one. Uh, okay, consider the case that an M1 is looking for a better connection while still sending via the old path. So this is the case uh, while moving through several cells or different wireless networks. Okay, so basically we have an old path and also we are looking for a better path. So after these steps of advertisement or solicitations, the MN can now receive a COA. So after this, MN will receive the COA, either one for FA or co-located COA. So after these steps of advertisement, MN can receive a COA, either one for FA or a co-located COA. The MN knows its location, the mobile node knows its location and the capabilities of the agent. Okay, the mobile node knows its location and uh, the capabilities of the agent. Okay. The next step for the M1 is the registration with HA, that is home address. Okay. If the M1 is in a foreign network, then the registration cannot follow in the normal style. So this is about agent discovery. So we have discussed agent discovery under four main headings: agent advertisement, two main headings: agent advertisement and solicitation. So normally every uh, home agent and foreign agent will send solicitation messages. By listening to that solicitation message, the the, the particular mobile station will establish a connection. And then we have discussed agent solicitation, agent registration. The first one is agent registration. The second one is agent solicitation. So if no advertisement packets are received from the uh, higher from the owner, if no agent registration packets are received uh, from the home agent and foreign agent, then the mobile nodes can send agent solicitation messages. In the mobile node can send agent solicitation messages requesting uh, requesting it to provide an IP address. Okay, so this is how the agent discovery is done in uh, mobile networks using mobile IP. Fine, thank you.